Hi guys, welcome back to my YouTube channel. I am Yasali and today we are going to learn about one of the most interesting and important classic problem in data structures and algorithm, the Tower of Hanoi. By the end of this video, we'll understand what the Tower of Hanoi is, how recursion is used to solve it, and how to calculate the number of moves needed. So let's get started. Let's start with the short story. Imagine a temple with 3 golden rods and a stack of discs of different sizes placed on one rod. The monks are moving the discs one by one according to the sum rule. When they finish moving all the discs, the world will end. That's the legend behind the Tower of Hanoi. But for us, it's just fun and logical puzzle to understand recursion. The main goal of the Tower of Hanoi problem is simple. Move the entire stack of discs from the first rod to the third rod using the second rod as a helper and a temporary rod. Sounds simple? But the catch is we must follow some rules. There are 3 important rules in the Tower of Hanoi. 1. Only one disc can be moved at a time. The second one is each move consists of taking the top disc from one rod and placing it on another rod. The third one is no larger disc can be placed on top of a smaller disc. That's it. These simple rules create a very interesting recursive problem. Now let's talk about recursion because Tower of Hanoi is the perfect example for it. Recursion means a function calling itself to solve smaller parts of the same problem. In Tower of Hanoi, to move n disc, we can think like this. Move the top n1 disc to the helper rod. Move the largest disc to the destination rod. Finally, move the n1 disc from the helper rod to the destination rod. That's exactly what happens in recursion. We keep breaking the problem down until we reach the simplest step. In every recursive problem, there is something called a base case. It's the point where we stop calling the function again. For Tower of Hanoi, the base case is simple. If there's only one disc, just move it directly to the target rod. No more recursion is needed. When there are more than one disc, we use recursion to solve the smaller problem. Let's say we have 3 discs. To move them from rod A to rod C, move the top 2 discs from A to B using C as a helper. Move the largest disc from A to C. Move the 2 discs from B to C using A as a helper. Notice something? It's the same repeated pattern again. That's the recursion. Okay, let's go through this example step by step with 3 discs. We'll name the rods A, B and C. And that's it. All 3 discs are now on rod 3 in the same order as before. It took us exactly 7 moves, and guess what? There's a formula for that. The formula to calculate the number of moves required for n disc is 2n minus 1. For disc 3, it's gonna be 7 moves. For disc 4, it's gonna be 15 moves. You can see how quickly numbers grows. That's the power of recursion. Let's see the simple recursive algorithm for Tower of Hanoi. This shows exactly how the recursive calls work. First move the smaller stack, then the biggest disk, then the smaller stack again. Now you might be thinking, where is this used in real life? Tower of Hanoi helps us understand how recursion and stack memory work in programming. It also used in backtracking problems, data organization, recursive algorithms like sorting and searching. So it's more than just a puzzle. It's lesson in problem solving. Students often make few mistakes while solving Tower of Hanoi. Forgetting the base case, mixing up the helper and destination roles, not following the move rule strictly. Always remember one disk at a time and no big disks on a smaller one. Let's quickly visualize everything we learned. Move n-1 disk from source to helper. Move the largest disk to destination. Move n1 disk from helper to destination. That's the complete recursive program. Let's summarize what we learned today. Tower of Hanoi is a puzzle with 3 rods and n disks. We use recursion to move the disk following 3 rules. The formula for moves is 2n-1. It helps us understand recursion and stack calls in programming. And that's all for today, guys. I hope you have a clear understanding of the Tower of Hanoi problem and how recursion works behind it. If you enjoy this video, don't forget to like, share and subscribe for more lessons on data structures and algorithms. See you in the next one. Bye for now.